Hey folks, this video is a continuation of my WebSockets series, which is a continuation of my intermediate Python series. Now, you don't have to have seen the whole intermediate Python series to follow this video, but you absolutely should have seen the first two videos in the WebSockets to make any kind of sense of this, because who comes in on the third part of a video series and expects to know anything, right? We will be making use of some of the things that we've been doing in the intermediate Python series, but it won't be hugely relevant to what we're going to do in today's video. In the whole big series, we're building up a Dropbox clone that's peer-to-peer and looks like this. Don't judge my UI. We do the prettying up of the UI in the last step. But it lets us share files, and it creates caches of those files, which show up here. And this is going to be really handy for this video because we are going to be doing file transfers. So I'll be using the database that's inside of the main program just to give us files to do transfer tests with, but that's it. Like, you won't need to have seen all the other videos to understand what's going on. The main thing is we have a file here, and we will be able to know where that is thanks to this database. It's telling us that it's right here. So let's jump into this. We're going to need to import OS and the main Dropbox program so that I can get access to its shares, which is just finding all of the share files that it's sharing. That's the only thing we're going to use from this. So if you're playing along at home and you're not doing the whole series, just do whatever it takes to get you a file. So when we left off here, we had made our system peer-to-peer, where it's able to accept connections from anybody, and it can establish connections with anybody. And it's doing all this asynchronously, so it doesn't break our UI. And right now they're communicating with each other, telling them their name and how many connections they have currently. And that's not very useful. So let's go to where they're doing that and start to really think about adding logic to this. This listener thing is where all the communication is happening. So here's where we would want to put in our program's, I guess, its own protocol of what it's expecting to receive as a message and what it's going to be responding to. So right now, all it's doing is listening to messages on the WebSocket and printing whatever that message is. And in the last video, I think it was the last video, we did our own little send and receive thing here, which is jumping over to self WebSocket send, and it's sending data as a JSON, and it's then receiving that and parsing that JSON and then returning the data to us. So we're able to communicate through JSON between different versions of this app, and then it goes straight into pure Python data, which is very handy. And because we're doing this self WebSocket thing, we don't have to do this await self WebSocket every time we want to do a message. We just need to do self send, and it's going to automatically do all the JSONing and sending for us. So we need to keep both of these steps in mind, though, when we're going down into our listener. So our listener right now is taking that raw message from the WebSocket. It's not using the receive process. That's used for our login when we're specifically expecting to receive very specific messages. So in order to make use of any new messages that are being sent to the WebSocket, we need to do that data conversion. So we need to say that our data is JSON load S. Load with the S means that it's going to do it securely. We don't really have to worry too much about security at this stage of our program because we've already gone through a very complex handshake process that should be establishing a secure connection. So we've now got this data. It's basically a Python dictionary. So we can just get a specific key from this, and the key that we want to be looking for is one that's going to define what type of message this is. We'll call that the op type or operation type. So we'll just do data get op type. And now this is where we want to start to parse this and figure out, okay, what kind of message are we getting and how are we going to respond to it? So one of the main messages that we'll get is if op type is equal to status, which is that thing right now where they're just sending their name and their connections. And here I'm just going to do like comments to indicate what we need to build into it, and we'll build into it later in the video here. So we're going to need to get a list of connections from this status message, and then we'll check to see if any of those are neighbors we are not connected to ourselves. And then we will want to check the shares, because this status message is going to include a list of all of the things that each client is able to share with everybody else, to see if we are looking for any changes to those files and compare those remote shared files against our own. So right now, it's complaining because we haven't actually included any code here. I guess we could print out self hostname status, and here we'll do a /n to make a new line, and here I'll just list the connections and the shares. And my groceries are here, so hold on a second. All right, I'm back, and we got good toilet paper. Oh my god, my fancy ass has not been enjoying the slim pickings that we've been getting. All right, where were we? So yeah, we'll do the actual code for these in a minute. Another message that we're going to be listening for is when one of the peers requests a file from us. So we're going to, let me do the print statement here. Requests file, and that will be data file name. So here we've got to prep like the whole process, because we're going to need to provide them a lot of details and let them know that, okay, we have this file and we're sending it to you. So prep all the file details that the recipient needs. Oh, I spelled recipient correctly. All right. And then actually send the file. And lastly, we'll be looking for this message, this all the details. So we're going to be looking for a sending op type, and this will be the host name confirms sending file data file name. And here we will take all the details for the file and prepare to, and I guess just, and receive it. So let's go through now and build up the prep work for all this. We're not going to actually do any of the checking the connections and stuff like that, but we should go into our status now and build it up the way that it should be built. So let's go back down. That was in our status update, where while it's true this is just a continuous loop that's running in the background, it's going to try to communicate to any of its connections that are in the state connected. This is super important. It's going to be really important in a second here. So let's give this some really useful information. And while I'm thinking about it, I need to set the op type here to status. So instead of just listing the number of connections, let's make a connection list that's going to have important details that our peers can use. So if they are looking at this list and they say, oh, hey, there's a peer I'm not connected to, it can establish the connection. So we'll need for connection in connections, we're going to need to connection list append, and here I'll make it a dictionary of the host name, and the URI, the identifier, that universal resource identifier, the connection string to get to this, which was, oh, actually it's not connection host name, it's connection host name, like that, because those are our classes that we're making. So yeah, that should work. Now we're also going to need a share list. And for share in shares, Dropbox shares, while I'm thinking about it, let me show you what this looks like. I'm going to make it pretty too. I'm going to from prettyprint import prettyprint, and we'll just prettyprint these shares. So you need to see how these are structured, because right now it's kind of a mess in this database file. So let's run this real quick. Turn off the client and just run this. So yeah, these are what the shares look like. They have an identifier and a cache, because we wanted to send the peers a file that we know won't be changed. Like if we are trying to send the specific file that we're watching, like the main purpose for this is going to be something I'm going to be using personally for when I'm doing machine learning stuff, where I want all the machines in my house that are equipped for doing that to be able to share the resources that they use in their training stuff. And if one of those files changes, I want to make a cache of that, because I don't want to change, I don't want any changes to be happening while it's transferring. So it's making two caches, the most recent and the last to the most recent. So it'll keep two copies of any file in case I need to go back to an older version. And it'll, in this case, we want to grab the most recent file and share that with anybody else that's connected and looking for that file. So when we get to the point where our peers are looking at our status and trying to decide, do I need this file? We're going to need to provide them with those details that they need. We don't need to send them the whole big list here, because it doesn't need all of this, but it will need some of the important details. So let us make a new dictionary here that's going to be the file name to identify what this is. It's going to be share file name, and you'll see that here. And then we need to drill into the cache list, and we want the most recent thing, and in this case it's going to be the second item. There are instances where there might be a third item in this list, so we can't just do one here to get the second item, because when it's doing the caching process there might temporarily be a third item, and that'll be confusing. So we can just do -1 here to always get the most recent addition to this list. And we'll need the shit, I'm making a mess of this. We need the cache modify date. All right, so here, oh, all right. So here we're grabbing the file name that's right here, but here we're getting into the most recent list item. So there's two here, there's this, and then the next one down. We're grabbing the cache modified from that list item. And now let's also get the cache hash. And I'm just going to copy this share cache -1 thing, because I'm going to be doing that a lot. We need the cache hash. And I'm trying to think, is there anything else we need? I think those are the only thing that's going to be relevant, really. Because we're going to be able to test, okay, is the modified date different from our most recent modified date? And is the cache hash different from our most recent cache hash? So yeah, that should be all we need in here. So now all we need to do is come down to where we're actually sending this message. And we're setting it up as a dictionary, which will be easily converted into JSON. So here I'll just give it the connection list. And then our shares as a share list. All right. Yeah, let's move on from there. So when we come back up to this, we'll worry about doing the connections stuff when we, in a much later video, when we're actually putting this back together with the Dropbox. And we'll also do the same with the shares. For right now, we'll do like a debugging thing where we're just going to make sure that it works. And I'm just going to automatically request grab me. But I don't want to always be doing that like on every single status update. So we need to do some things to make sure that that doesn't always happen. The first is I'm going to set a global here of grabbed to false. And since we're inside of a class instance, we need to declare that we're using that global. And there are some people who think that you should never do this, but we're using this as a debugging thing. It's fine, all right? So don't complain. So if not grabbed, and I only want the client to be doing this because if they're both trying to do it at the same time, it's going to be a mess. Hello, my name is, and that is client. So if we haven't grabbed it, then first thing we need to do is set it to true, assume that we have grabbed it. Now we want to do the requesting portion. We'll say, okay, we're assuming that this is a file that we want from our peer, so we're going to do an await self send, and here we send the request message of the file we want. So we op type request, and file name is grab.me. I'm having this conflict of wanting to like really explain this and like how easy it is, but on the other hand, I want to be moving really fast because I want to be the one guy doing really deep programming tutorials that you don't have to put on 2x speed on YouTube. So this is all it takes though. Like we've structured our protocol to be very simple, where we just say I'm requesting and this is the thing I'm requesting. And that's when we get down to this portion where where I'm on the other end of this. I now receive this request for this file. I should check to see if I've got this file. So for share in Dropbox shares, and again, if you're not doing this as part of the whole series, just do whatever it takes to get a file here. If share file name is equal to the data file name that we just got a request for, and we got the file, we can send it to them. So here we need to do all this prep work that we were talking about. So we need to get I guess we're going to need the cache hash. We're going to need a lot of this, actually. We're going to need the cache hash and the cache modified. But we're also going to need the cache path so that we know where we're storing the file. So let's try to do this in the same order that I was doing it before. Is going to be equal to share cache, and then that last list item, cache modified, and then cache hash is cache hash, and now the cache path is equal to the cache path. So now we've got all this. We can send a message to let them know that we're acknowledging this. So let's await self send, and here we'll say op type is sending, and we'll just give them all those details. We know already what the file name is because we've got it up here, but I guess we could be doubly sure if we set it here to being, or no, that's not in the cache, it's just the share. All right. And then we need the cache hash, or doing this in the order that I did it before, cache modified and cache hash. All right, pretty that up. Now, this is where we will go into sending the file, because we can't use the send that we've got here. That's going to try to convert everything into JSON, and that's definitely not going to work for most files. So we need to create a new method specifically for file transferring. Let's do that right now. So we'll go to where we're doing our send and receive and create a new one. It's going to be async. And oh shit, I just thought of something. Am I awaiting these sends? I am. Okay, I'm awaiting that one. I'm waiting that one. I always forget that. I wanted to double check it while I'm here. All right. Async def file send. And for this, we just need a file path. Yeah. And this is going to be relatively easy. Trying to think. All right. We're going to break it up into chunks and make this a loop so that we can, if we've got a really, really big file, we don't break everything else in our program. We can have it in these small chunks, and that way we can do a sleep, and it lets all the other asynchronous stuff happen. So we'll set a variable of sending to true, and we'll open up the file that we want, which is going to be this file path. And we're going to be doing this in bytes. So we need read B here for read bytes. And we're opening that as a context called F. And we can now create a buffer by just reading a specific byte number from that file. So it doesn't matter how big the file is, it's going to try to read 8,192 bytes of it. And it's going to put that in the buffer. And if it's got less than that in that file, it doesn't matter. It's just going to grab whatever. If it's got more than that, it'll do this in chunks. If we put this into the loop as I intend to while sending. All right. And now, if we get to the end of the file, the buffer is going to be empty. So if not buffer, we need to indicate to the recipient that we're at the end of the file. And the best way to do that is to tell them that we are at the end of the file, EOF. And whether the buffer is actual data or the buffer is EOF, we want to send that using the WebSockets send and not our own send. Because this WebSockets send will determine, okay, this is bytes, and automatically send it as a bytes thing. It's going to be fully automatic for us here. And when it gets to the end of this, it will break out of this. If we tell it here that sending is now false. And there's a few things that we want to do here. The main thing that we need to do is do a async IO sleep, so that every time it goes through this sending loop of 8,190 bytes, it sleeps for a little while to let any other processes happen. And we also want to change our state so that we keep track of that. Because remember that the status thing is always trying to send its status to other peers. And if it tries to send that status message while it's doing a transfer to that, it'll stuff the status into the data that we're sending, and that's going to make a mess. So we don't want that. We need to keep track of our states. It's a really important thing in all of networking. So let's set our self state to transfer. And then at the very end of all of this, when we get out of our with and everything, we set it back to connected. And then it can resume sending us status updates. And that should be it. I kind of want to do something in here that's going to let us know that this is happening. I'll just do a sending chunk. Okay. I think I did all that right. Let's now make a receiving method. And this one is going to need a lot of details because we're going to need to make the place that we're going to save this to. And we're going to need to be able to check its hash against the hash that we are told that it's supposed to be versus what we actually download, so we make sure the download worked correctly. So we'll need the file name, the cache modified and the cache hash. And the first thing that we need to do is actually set up the directories for our file to save to. And we will do that by saying that our cache path is going to be, and man, every time I do anything with the OS path join, it gets messy, but we're going to say that it's joining our current working directory, and then it's going to add a slash cache to that, and then it's going to add, remember we got this naming convention of the file name underscore and then it's cache modified time, so it'll be file name here underscore cache modified, and we need to norm this so that it works correctly across all operating systems. All right, I think I did that correctly. And now we need to actually make that directory. So we'll use the make dirs in case we're missing the cache directory. It'll automatically do that and everything underneath it of this cache path. Yeah. And now we're ready to actually begin receiving the file. So receive the file. We're going to do it in a loop because we know that it's going to be coming in these buffered chunks. And we'll do it slightly differently, but it's basically going to be the same thing where we're going to say that buffer is equal to await self WebSocket receive. And again, the WebSocket receive method will know it's getting a bytes object and it will give us a bytes object. If not buffer, or no, in this case, we have to check if we've got that end of file thing. So if buffer equals :EOF, we want to break out of this loop that we're doing here. But I'm trying to remember, do I want to, I think I want to open up the file first. So let's do that. Let's open, here we're going to have to do another join, OS path, join the cache path, path that we've created with the file name that we're going to put in here, so we get just a regular file at the end of all this. And we don't need to norm this because it'll figure it itself out on its own. And we're going to open that as F. And yeah, this should be fine. So we get our buffer, and if we get to this point, it's going to break. But if we get past this point, then we've got buffer that we need to write into our file. So let's write, oh shit, I nearly forgot to write it as buffer. Make sure that you open a file for writing in bytes, because that is definitely not the default behavior of open. So if you don't do the comma WB here, it's definitely gonna break. We should probably also set our state somewhere. And at the end of this, put it back to connected. And let's do a got chunk, so we know that a file or chunk has come through here, and we need to await. Yeah, we'll just do a sleep here. We're not going to worry about the hash right now. We'll worry about that later. Like, make myself a to-do note here. Verify our hash, our local copy hash against remote hash. All right. Well, we'll do that later. So we've got our sending and receiving now. We come back to where we're writing these messages back and forth to ourselves. We're ready to do the send file. So we've sent a, hey, we're sending it, here's what to expect. Now we can do an await self send. And remember, we told this that it's only going to expect, file send. We told it we're going to send it a file path. So we need to, once again, do a OS path join here because of the way that this is structured. We've got the cache path, but we don't have the file name at that path. So we need to join the, oh shit, this should be in here. So we'll send the cache path and the file name. That should be all that it takes to do that. I want to point out something that's really cool about Python. Like, a lot of people have a hard time with Python because of the hard white space rule where you have to be indenting things. But that just saved me from screwing up really big, because I was going to put this outside of the scope of this, and that would have definitely broken things. It looked wrong though. So my brain, even though I'm talking to you and it's using up so much of my brain to be able to communicate while I'm programming here, I was able to see that and like, wait, there's something wrong about the way this is lining up. And then I was able to push it in. So this should all work. Let's now move on to the other end of this, where we're now getting all these details. We will, I guess, all we really need to do is just send this now to our file receiver with these details that it's going to need. So wait, hold on. I don't actually want that to be a dictionary. I want to just get the data. Yeah. So we're going to get that, and we're going to get a data cache modified. And this is why I kept on trying to make sure I was doing the cache modified and the cache hash in the same order, because I don't even have to look at it right now. That's the way I've always been doing it in this. So I know that that's the way that this is expecting to receive those data bits. And I guess we could do something like download complete for at the end of that. I think this is going to work. Let's give this a shot. Make sure everything looks pretty. All right, so as a refresher here, the client here is basically just me taking this peer-to-peer thing that we've got and breaking it in half, where it's just using the port scanner portion, which is how it connects to other things. So I'm not cheating. This is just using all the code that we've built in all that process. It's grabbing it all in the networking portion, because when it goes to this port scan, it's creating these connections, which are those classes that we've been writing those methods into. So let's fire it up, see what happens. All right, I should get rid of that. Let me get rid of a lot of the debugging messages so that we're clearly seeing what's happening. We don't need to print this anymore. All right. So now the server portion is up and running, and now I'm running this, and it's connected to itself, and we have a new connection from client, and it's already jumped over to sending chunk. Like the client requested the file, and we started sending the chunk. And over here, we're going to see like a whole bunch of got chunk, download complete. And let's check to see if we actually have a copy up here. It should show up over here. Sometimes PyCharm doesn't refresh these directories. We should see a second grab me now in the cache. And we do. This is the new one that was created just now. Oh, that's perfect. It worked. I seriously cannot believe I just pulled that off in the first try. I'm going to go now for broke, and I'm going to try to... I've got this code set up on my laptop. I'm going to see if I can get the laptop now to work. Okay, so the way I'm setting this up, I've turned off the local server here. Let me go to the port scanner portion of this and increment this up a lot so we're not sitting around waiting for this to connect. So if I now run the server portion on my laptop, and okay, it's now running, I can launch this client thing and see if it is able to grab it from there. So it is connected. Oh, something broke. Oh, because it already exists. All right, that's fair. Let me delete that. Oh, shit. PyCharm just gave me a scary looking error. Well, according to this, it's not there anymore. All right, let's try this again. All right. It's connected to the laptop. And we did request, and it's sending it. Got chunk. Let me scroll all the way down here. It's a 20 megabyte file, so it probably did way faster than I could scroll down. It did successfully do it, according to it. Let's verify that now. And it did. Oh my God. I seriously cannot believe I just pulled that off on video. Like there were no errors other than there being a existing file when I tried to download another copy of that file. But that worked, and like we're connected, and it's doing all the messaging, and they're talking to each other. I'm really, really happy about this. I'm so happy to see this actually working with the laptop. Like this is, it's doing everything we told it to do. Like it should be doing this, but it's actually working, and that's amazing. Like I'm really, really excited. The next videos we're gonna transition. We're gonna start to transition away from all these WebSocket stuff into rebuilding this into Dropbox. But before we do that, we're going to have a detour into cryptography, because cryptography is one of those things where you do not want to fuck around. Like it is a serious subject, so we're going to treat it very seriously and like dedicate an entire episode, at least one episode to it, maybe two, where I'm going to really cover very good, grounded security principles in cryptography so that we make sure that our connections are actually secure and that people aren't going to use what we're making here to then hack ourselves or something. Thank you very much, all my Patreon patrons, for making these videos possible. Take it easy, folks.